Clear. Clear out.
As doctors, nurses, and medical technicians, we depend on a vast array of biomedical equipment to assist us in treating and caring for the patient. At a major Army medical center, the biomedical equipment inventory may include up to 20,000 items. The availability and dependable operation of this equipment is crucial to proper diagnosis, treatment, and often the very life of the patient. Much of this biomedical equipment is in daily use. Some pieces are one of a kind and cannot be immediately replaced. Other equipment is relatively simple and usually in adequate supply. To allow us to provide the best in patient care, our biomedical equipment must receive the best maintenance care available. These men and women are training at the U.S. Army Medical Equipment and Optical School, which has become the model for civilian training programs throughout the country. As military medical professionals, we're extremely fortunate to have our own biomedical equipment maintenance and repair staff on call 24 hours a day. The availability of such staff expertise is a key factor in efficient biomedical equipment maintenance and also contributes to a significant savings in both maintenance and repair costs. A part of the Army's Academy of Health Sciences, the school is located at Fitzsimmons Army Medical Center in Aurora, Colorado. Since the school is geographically separated from the academy, we're going to use this film to familiarize you with the medical equipment training program. Then we'll show you how a biomedical equipment section interacts with the medical staff to support the maintenance needs of a major medical center. The school's training curriculum is divided into a basic and an advanced course. In the basic course, students learn to install, service, and repair mechanical and electromechanical equipment. Items such as this respirator, dental equipment, and sterilizers.
This morning we're going to go into Circuit 4. Circuit 4 has 4 major components. We have the time delay, we have relay K3,
Basic students begin by studying electrical fundamentals and simple mechanical components.
Switch 1 to the 2-3 position. Doing this, we energize T1.
Initially, theoretical concepts are put into practice through laboratory troubleshooting exercises. The basic students then move on to analyze and troubleshoot malfunctions in a variety of actual equipment available to the school exclusively for training. The students get hands-on maintenance experience with dental operating units which combine electromechanical components with pressurized water, air, gas, and hydraulic systems. They learn about pulmonary equipment, such as this anesthesia apparatus, which must operate precisely with zero tolerance for error. They also learn to service sterilizing equipment, which utilizes higher amounts of electrical energy, as well as steam pressure, and some totally electronic components. Basic course students are also introduced to a number of other types of medical equipment. This variety prepares them for the diverse maintenance and repair needs they'll encounter in the field. The goal of the basic course is to teach the students concepts which give them the ability to analyze typical electromechanical components. For example, this training unit is equipped with a series of controllable malfunctions, from simple to complex. By activating various combinations, the instructor teaches the student to analyze components in a logical order. The approach prepares the student to apply troubleshooting concepts to any type of electromechanical device, even if they've never seen that specific equipment or model before. The fact that this concept approach is taught using the latest medical equipment, which the students will probably service in the field, is an instructional bonus made possible by the school's exceptional equipment inventory. Throughout the training program, safety principles and practices are stressed.
We talked about how much pressure these gases are under earlier, and we said the cyclopropane was under very low pressure, so we don't use a regulator with it. When or before we hook up a regulator, we always open the valve slightly.
Could you tell me why you open it slightly?
The students are taught to appreciate and avoid the potential safety hazards associated with each maintenance situation.
Lubricants, oils inside the regulator. Now be sure that this valve or the opening.
After completing the basic course, students are assigned to biomedical equipment repair units attached to field medical activities. This might be at a major military medical center or with a direct combat support medical unit. To continue their academic training during this initial assignment, basic course graduates are encouraged to participate in the school's Medical Academic Preparatory Correspondence Program. Subjects include Introduction to Military Medicine and Surgery, Algebra, and Electricity.
We're discussing RC time constants, or resistive capacitance time constant. Now this deals with the amount of times it would take a capacitor to charge from its minimum level, 0, to its maximum applied voltage. It would take us 5 time constants to completely charge this capacitor.
After an initial assignment at a field activity, selected students return to the school for the advanced course. Here they broaden their theoretical understanding of electricity, then go on to master the principles of solid state and digital electronics. This advanced training is a prerequisite for maintaining today's highly sophisticated electronic biomedical equipment.
Remember that when we were monitoring the power supply on the RD2, the 250 volt range, we have to monitor the power supply on this unit also, except that the tolerance,
as in the basic course, the training approach in the advanced course continues to be concept-oriented.
And then clip onto the top of it to monitor our 12 volt range.
The advanced students learn the electronic concepts and the logical troubleshooting procedures, which enable them to analyze malfunctions, even in unfamiliar pieces of equipment. Now that you're familiar with their training program, let's follow 3 members of a biomedical equipment repair section as they carry out their daily assignments.
Special spray, sometime today I would like you to go by the A and B lab. And
like all military missions, successful biomedical equipment maintenance requires proper planning, efficient execution, and experience. Sergeant Wright, the section supervisor, embodies these key concepts. Specialist Trey is one of Wright's most experienced repair technicians.
Specialist Judd, I have a work order here for you on an electric bed on Ward 57.
Specialist Judd is a recent basic course graduate, getting her initial job experience. In this instance, the mission involves the complex maintenance needs of a major Army medical center. But the operational methods shown here apply in principle to all medical activities, regardless of size.
Since I've arrived here at the medical center, I've really gained a lot of new experience, not only in equipment repair, but in developing a sound working relationship with the hospital staff who depend on the equipment. And that's an important factor in doing a better maintenance job.
May I help you?
Yes, I'm from medical maintenance. I'm here to fix your bed.
Parker, would you show it to me? Sure. Follow me, please.
In the 6 months she's been in the section, Judd's responsibilities have steadily increased. She's gained experience in servicing a variety of basic medical equipment.
I was a little nervous about my first few field assignments, but my confidence has really increased now that I've had the chance to apply some of the things I've learned in the basic course. I'm getting eager to work on some of the more sophisticated equipment, but I still realize the important contribution to patient care I'm making by maintaining some of the more basic hospital devices.
How's everything going?
Fine, the bed's working properly now. I replaced the switch and I repaired the tension in the spring. My next goal, after I finish my tour here at the medical center, is to attend the advanced course at USA Meals. And I'm taking the required correspondence courses now to make sure that it happens.
Specialist Prey has completed the Biomedical Equipment Advanced course. His training and experience have made him proficient at repairing all types of medical equipment, including sophisticated solid-state and digital electronic components.
How's the heating bath on the CPK that I fixed for you last week?
It's been working really well. It's a little bit warm.
One of the most challenging aspects of my job is keeping up with the rapid advances in electronic technology.
And it's been holding steady. I haven't been getting the shifts anymore. It's been running in control.
Advances in equipment sophistication have required biomedical equipment personnel to expand their skills into many new areas of technology. Increasingly stringent government regulations such as calibration and compliance testing for radiological systems have added further skill requirements.
You watch the B screen. The transducer will pick up the signal that you're scanning.
To meet these and other advanced educational needs, the Biomedical Equipment School offers a series of functional courses to qualified repair personnel.
And send it over to the B screen, where you'll see right here the image of what you were looking at, whether it's a kidney or a fetus or whatever.
Morning, Major.
Good morning.
I'm having an in-service this Wednesday, and I'd like for you to attend if you could.
In-service on what?
It's going to be on the cardiac monitors. Today's in-service is on the care of your monitors. All you need to take care of these monitors is a little soap and water. One of my responsibilities is to share my knowledge about new and current equipment with the hospital staff. It can be very dangerous.
Maintenance on right now, have you?
Yes, this is Captain Tickinen on Ward 46. Our cardiac monitors have gone out.
Okay, I have someone come up and check it out right away.
Maintenance is not always scheduled. Sometimes repairs may be necessary under emergency situations, with patients' lives in the balance. Such critical equipment malfunctions require quick action from both the staff and the repair section. But effective emergency repair procedures don't just happen. They must be planned and coordinated. Planning, coordination, and overall maintenance management is the responsibility of the biomedical equipment supervisor.
Oh, good. It's coming back on.
Very good.
It's working just fine.
Success of our maintenance program, from routine inspections to emergency repairs, requires effective coordination between the repair section and the hospital staff.
Take the old one back and fix it up in case a problem ever happens again. We'll have a quick fix right for it.
Sergeant Wright, I have some questions regarding the piece of portable unit that we want to acquire. Specifically regarding the warranties, what is covered?
The manufacturers give a one-year warranty on the controls.
Another important function of the biomedical equipment supervisor is providing advice on the selection of new medical equipment.
From a maintenance standpoint, we believe that the gas operator would be more appropriate because we fill it up once.
When planning for a new purchase, he can provide valuable input concerning compatibility with existing equipment, ease of repair, and the best procedures to follow for maintenance.
Sergeant Wright, thank you very much. Your information has been most helpful because I would have thought the battery-powered would be the unit we'd want, but I think the gas-powered is the item we should purchase instead.
Sergeant Wright uses a number of sophisticated management aids to keep on top of the medical facility's maintenance needs. These include computerized repair records, equipment calibration requirements, and preventative maintenance schedules. This tag represents another key management aid, the Biomedical Equipment Maintenance Control System.
To determine how much money has been expended on a certain piece of equipment. It also determines the amount of PM and electrical safety that is due on this equipment. There are three primary factors.
The control system helps Wright make the most efficient use of his maintenance resources. And efficient maintenance translates into maximum availability of equipment to assist all of us on the medical staff in our patient care mission. The men and women who maintain and repair biomedical equipment receive a high level of technical training. They're provided with the best tools and testing devices. And they utilize the latest in management aids. But to get the most out of their training and tools, they need our understanding and cooperation. In today's high-technology environment, a close working relationship between the biomedical equipment operator and the biomedical equipment maintainer can go a long way towards ensuring continued high-quality patient care. We're extremely fortunate to have our own biomedical equipment maintenance and repair staff on call 24 hours a day. The availability of such staff expertise is a key factor in efficient biomedical equipment maintenance and also contributes to a significant savings in both maintenance and repair costs. A part of the Army's Academy of Health Sciences, the school is located at Fitzsimmons Army Medical Center in Aurora, Colorado. Since the school is geographically separated from the academy, we're going to use this film to familiarize biomedical equipment to assist us in treating and caring for the patient. At a major Army medical center, the biomedical equipment inventory may include up to 20,000 items. The availability and dependable operation of this equipment is crucial to proper diagnosis, treatment, and often the very life of the patient. Much of this biomedical equipment is in daily use. As doctors, nurses, and medical technicians, we depend on a vast array of you, with the medical equipment training program. Then we'll show you how a biomedical equipment section interacts with the medical staff to support the maintenance needs of a major medical center. The school's training curriculum is divided into a basic and an advanced course. In the basic course, students learn to install, service, and repair mechanical and electromechanical equipment. Items such as this respirator. Dentally, some pieces are one of a kind and cannot be immediately replaced. Other equipment is relatively simple and usually in adequate supply. To allow us to provide the best in patient care, our biomedical equipment must receive the best maintenance care available. These men and women are training at the U.S. Army Medical Equipment and Optical School, which has become the model for civilian training programs throughout the country. As military medical professionals,